Alright, welcome back guys. We're going to go over this material, the support material for section 2.4. Okay, so this first it says product rule for exponents. This pertains to exponential expressions, so basically expressions that have exponents in them. It says often we will be multiplying a power of a variable by another power of the same variable. So for example, if we had here x to the second power times x to the fourth power. So anytime, well, first of all, let me define a couple things. When you have an exponential expression, let's say x to the second power, the x is called the base, and then the 2 in this case is called the exponent. Okay, so when you're multiplying two exponential expressions, if the bases are the same, like in this example, x to the second times x to the fourth, then you actually add the exponents together, and that's what this property here in the box is telling us. It says for any number a, and with integers m and n, a to the m power, so m and n just are representing numbers. So a to some power times a to some other power is going to give you a to the sum of those two powers. In other words, you add those exponents. So, you know, that example we were considering, x to the second times x to the fourth, since the bases of each of these expressions are the same, you just carry over that base and you add those exponents, and that becomes your new exponent. So that becomes x to the sixth. So that's essentially what the product rule says. I'll give us a couple other examples. What if we had a to the third times a to the seventh? Well, again, these bases are the same. They're both a's, so we can add those exponents. And this will become a to the 10th, because 3 plus 7 is 10. Really what you're doing here, guys, if you have a to the third power, that's literally 3 factors of a. So that's like a times a times a, 3 of them. And then when you multiply that by a to the seventh, that's essentially 7 more factors of a. So you're just adding up all those factors of a, and there'd be a total of 10. Now let me give you a couple other examples. What if we had, you're probably not going to see this one, what if you had x to the second times y to the third, and you multiply that by, we'll say, just x times y. Well, you may say, well, you know, this first x and this first y, they both have exponents, but these last two don't. Well, anytime you encounter that, everything has an understood exponent of 1. Sometimes it won't be written. Most of the time it will not. So you can actually give those latter x and y factors exponents of 1. So what you could do is you can multiply your two x's, x to the second times x to the first, since those bases are the same, and add those exponents. So this 2 plus 1 is 3, so that's going to give us x to the third, or x cubed, and then multiply your two factors of y. Y to the third times y to the first, 3 plus 1 is 4, so you're going to get y to the fourth. So the product is x cubed y to the fourth. Now let's do one more example, and this is going to be an example in which you cannot add the exponents. So what if we had maybe c to the fifth times d to the sixth? You cannot add the exponents in this case. And the reason is because these bases are different. One is c and the other one is d. Okay, so be aware of that. The bases must be the same. Okay, so that's something you're going to need to know. Alright, so now let's continue. Let's look at multiplying something called a polynomial. If you look at the word polynomial, I'm going to write it. The prefix right here, guys, poly, means many or more than one. So a polynomial is a mathematical expression in which there are several terms. It could actually just be one term, in which there's one or more terms that are being added or subtracted. Okay, so an example of a polynomial would be, I'm going to just make one up, 3x to the fourth minus 5x to the third plus 2x squared, let's say minus 7x plus 10. This is a polynomial, and this polynomial has 5 terms in it. The terms are the pieces that are separated with either addition or subtraction. So the first term is 3x to the fourth. The second term is negative 5x to the third. So if there's a minus in front of it, look at it like it's a negative number, negative 5x to the third. The third term is 2x to the second. The fourth term is negative 7x. And the last term we call a constant, because there's no variable with it, is just 10. So this polynomial actually has 5 terms in it. Now what we're going to do is look at multiplying different types of polynomials. So depending on the number of terms that the polynomial has, the name will be different. So you could call it a polynomial, but if it only has one term, you can be more specific and call it, if you look in this box, a monomial. So in this case, that prefix mono means one. Okay? So if you read the definition, a monomial is a constant or a constant times some variable. Okay? It's basically one term. It's a polynomial that has exactly one term in it. And there's some examples right here in this box. I'm going to zoom in. So a monomial is a polynomial that has exactly one term. So an example would just be 4. Another example would be negative 3p. A third example, although we won't really see this type in this class, would be this term right here. And the reason I know that this is just one term right here, guys, is because there's no plus or minus between the a and the b. This is all one term. Another monomial would just be the term 0. Alright, and then we have a specific name for a polynomial that has exactly 2 terms. So if you look here, again, let's go by the prefix, which refers to 2. So a binomial, okay, it's a polynomial with exactly 2 terms. And this is an example, 2x plus 7. This polynomial has exactly 2 terms. The first one is 2x, and the second one is 7. Here's another example. A squared is the first term, and then negative 3b is the second term. And then here's a third example of a binomial. So you'll hear this terminology a lot throughout the course. And then finally, we have what's called a trinomial. So that prefix, tri, refers to 3. Think about, triceratops or tricycle. Triceratops had 3 horns. It was a dinosaur. So these are polynomials with exactly 3 terms. So x squared minus 7x plus 12. That's a trinomial. We'll see a lot of these in this class. Now you may say, well, what about polynomials that have 4 terms or 5 terms or 6 terms, etc.? Well, we could give those names, and they do actually have names, guys, but we're not going to worry too much about that, because we're not going to see very many polynomials that have more than 3 terms. Alright, so now that we know what a polynomial is, let me say one other thing. These polynomials, all of these terms, the x's have positive powers. So 4, 3, 2. This x right here with the 7 has an understood power of 1. So the variables will always have positive integer powers. Furthermore, you will never have an x in a denominator, in a polynomial. Alright, so now what we want to do is learn how we can multiply these polynomials. So we're going to look at example 1, and it deals with, it just says multiply. But if you look here, we've got 2x to the 4th power times 3x. So really what we're doing is we're multiplying these two terms. So these are really just two monomials being multiplied. You got one monomial, which is the 2x to the 4th, times the other monomial, 3x. So the way you multiply these is you're going to multiply the coefficients first. So you think back, I know I've mentioned this, the coefficient, guys, is the number that's in front of the variable. Okay? So the coefficient of the first term is 2, and the coefficient of the second term, or the second monomial, is 3. So you're going to multiply 2 times 3, and that's going to give us 6. And then you're going to multiply your powers of x. And this is where this product rule comes in. Because when we're multiplying two powers of x, we can add those powers. So let's look at the second x. It doesn't have an exponent, but I can give it an understood 1. So if we have x to the 4th power times x to the 1st power, and add those exponents, we're going to get x to the 5th power. So the product here is 6x to the 5th. So we get another monomial. Alright, now let's try another one. This is actually the same type of problem. This 2x is one term, so this is one monomial. And guys, what we have in parentheses is another monomial. How do we know that it's a monomial? Because it's just one whole term. There's not a plus or minus sign between the x and the y. It's just one whole term. It's a negative term, but it's still one term. So we'll multiply the way we did the last one. We'll multiply our coefficients first. We have a 2 times this negative 10. It's going to give us negative 20. And then we'll multiply our powers of x together. So we've got two of them. Remember, this first x again has an understood exponent of 1. So x to the 1st times x to the 2nd is x cubed, or x to the 3rd. And then you may say, well, what about the y? There's not another y to multiply it by. That's true. So what we do is we just carry this y over. So this is our product, and it's another monomial, negative 20 x cubed y. Yeah, and I put this in the notes. It says if the variables are different when multiplying, you do not add the exponents because the bases are not the same. Okay, so let's get into some other stuff. Let's look at this next one. It just says multiply. What we have here is we're multiplying the 7a to everything that's inside these parentheses. So the 7a is just one term, so it is a monomial. But in the parentheses here, guys, we actually have three terms. b, and then negative c, and then d. That's three terms there. So that's actually what we call a trinomial. So, the way you're going to multiply a monomial to a trinomial is you're going to use the distributive property. You're going to distribute that 7a to all three of those terms in the parentheses. Really, you can look at all of this multiplication as just really utilizing the distributive property. Alright, so when I use the distributive property, guys, you may have noticed in my videos, I like to draw arrows, okay, to show that I'm distributing to all those terms. And furthermore, you may say, well, the b, the c, and the d, they don't have numbers, or they don't have coefficients in front of them. Well, they do, they're just not written. Remember, they're understood ones. So you can write them if you want or not, but you've got to know that they're there. Oops. So 1D. Okay, so when I start, I've got a 7a times 1b. So you'll multiply the 7 and the 1 and get 7. And then you'll multiply the a and the b together. Well, these two are different. Okay, so we will not add their exponents. In fact, since they're different, guys, we just write it ab. So we get 7ab, and then we distribute to the second term. So we have 7 times this negative 1, which is a negative 7. And then we have an a times a c. Well, those are different again, so I just rewrite them. So negative 7ac. And then finally, the 7a times the 1d. 7 times 1 is 7 again, but it's positive, so I'm going to put a plus sign. And then the a times the d, we're just going to write AD. And that's pretty much it. That's really all we can do. Technically, after you multiply, you're supposed to look and see if there are any like terms that you can combine. But these terms are not like, guys, because although they do have A's, they don't all have B's, or they don't all have C's or D's. So they're actually all different. These are three unlike terms. Okay, let's go to example 3. What about multiplying two binomials? So a binomial is a polynomial with exactly two terms. It says we can use what's called the FOIL method. Okay, so you may remember this from high school. This word FOIL is an acronym. Each of those letters represents a word. I don't really like to use this, guys, because it's not very mathematical, but I'll list it anyway. So the F represents first. That means you multiply the first two terms in each of the binomials together. And then the O represents the word outer. Okay, which means you multiply the outer two terms of in the binomials. And then the I represents the word inner, which means you multiply the two inner terms. And then the L represents the word last, so the last two terms would be the negative 3r times the positive 3r. So you can remember this acronym if you want, that's fine. The way I look at it is like this. Like I'm just using the distributive property. The only difference is, in this second set of parentheses I have two terms. So I'll be distributing to those two terms. But in the first set of parentheses I have two terms. So what I have to do is distribute the first term first and then move on to the second term. So this is what I mean. Multiply the 4p to both of those terms. So let's do that first. So the 4p times 4p. Well, 4 times 4 is 16, and p times p, remember they have understood exponents of 1, so that's going to become p to the second, or p squared. And then we'll move on, 4p times 3r. Well, 4 times 3 is 12, and p times r, those are different, so I'm just going to write them pr. The order there doesn't actually matter. You could write p times r or r times p. Alright, so I've distributed the 4p to everything in the second binomial here. So now what I'm going to do is distribute the negative 3r, the second term. I'll do it the same way. So negative 3r times 4p. Negative 3 times 4 is negative 12. And r times p, you could write rp, which is fine. But what's going to happen here in a minute is we're going to try to combine like terms. And so if you notice these two terms right here, these are like. The reason I know that is because although the p and the r are out of order, the variables are exactly the same. Okay, so for that reason, in this third term, I'm going to change the order of those two variables. I'm going to put PR. And actually, let me make a note right here. I'm going to say that order does not matter. The reason it doesn't matter is because you're multiplying. P times R is the same thing as R times P. Just like 2 times 4 is the same as 4 times 2. But I like to write it such that it's easy to identify that these two in the middle are going to be like terms. And then finally, I'll distribute the negative 3R to the positive 3R. Well, a negative 3 times a positive 3 is going to give you a negative 9. Let me change that to a negative. And then the R times the R, remember they each have understood exponents of 1. So when you add them, you're going to get R squared. Alright, now, remember a second ago I said lots of times after you multiply, the last step is to look and see if any of these terms are like. Well, it's the two in the middle, okay, because they each have one factor of P and one factor of R. So we can combine those. They're like terms. The issue, though, is that when we combine them, 12 minus 12 is 0. So technically we should get 0 PR. But guys, 0 times anything is 0. So you're not going to have anything left from those two terms. Or in other words, you can think of it like they cancel each other out because they have opposite signs. Okay, so they are like terms. When we go to combine them, they turn into 0. And so that means all we have left is going to be the first term and the last term. So you're just going to bring those down. So 16p squared and then the minus 9r squared. And that's our result. So we multiply those two binomials in parentheses, and we actually get another binomial right here. Alright, well let's try the second one. The second one is the same way because these are two binomials. So I'm going to start by distributing the r. R times r is going to be r to the second, just like right up here. And then r times negative s. Well, that's going to give us rs, but you can also think of it like we're multiplying a positive 1 times a negative 1. And that's going to give us a negative. It's going to be a negative rs. You can rewrite it like this if you want. You can put 1s in front of those variables if it makes it easier. But hopefully you'll get to the point where you won't need to do that. Alright, so now I'm going to move on and distribute the negative s. So negative 1s, or you can look over here, times 1r will give us another negative rs. And again, I changed the order to match this term that I just put down. So I can see that these are going to be like terms that I can combine here in a minute. And then finally, we'll multiply the negative s to another negative s. Well, a negative times a negative is a positive, and s times s is s to the second. Okay, so we get s squared. Alright, so now these two terms in the middle are like. You can put little 1s in front of them if you want. They both have exactly one factor of r and one factor of s, so we can combine them. Now these are not going to cancel though because you have a negative 1 minus 1. If you were to check this in your calculator, guys, that's going to give you negative 2. They'll only cancel if the signs are opposite. So you get negative 2 rs from those two like terms. And then the first term here, the r squared, and the last term, the s squared, these are unlike. So all we can do with those is bring them down, and they become part of the product. Okay, so this is our result. And this, by the way, is a trinomial. It's got exactly 3 terms. So multiply these two binomials and we get this trinomial right here. Alright, now let's do one more. This last one in which we're multiplying two binomials again. So we'll do it the same way. So we'll say x squared times x squared. Remember, add those exponents. And then x squared times negative 3y to the second. Well, if there's an understood 1 in front of the x squared times the negative 3, that'll give us negative 3. But the variables are different again. This is an x squared and this is a y squared. So you just rewrite them. You can't add their exponents. And now we're going to move on and distribute the negative 2y squared. So negative 2 times an understood 1 is negative 2. And again, these variables are different. So I'm going to rewrite them, but I'm going to put them in the same order. I'll put the x squared first and then the y squared second. And then finally, we've got the negative 2y squared times the negative 3y squared. So the negative 2 times the negative 3 will give us a positive 6. And the y to the second times another y to the second will give us a y to the fourth. Alright, and then my last step is combine any like terms. Lots of times when you're multiplying binomials like this, many times, guys, the two terms in the middle will be like. Not always. But in this case, they are. Each of these two terms has exactly an x squared and a y squared. So we can combine those. So the negative 3 minus the 2 would give you a negative 5. And since we're combining those terms, you just leave the variables the same. And that's a positive 5, so I'm going to put plus, and I'm going to bring down my x to the fourth, and then bring down my 6y to the fourth. And so that's it. This is now another trinomial. This is what you would call a trinomial in two different variables, because we have both x's and y's. So we won't see many of these in college algebra. Okay, and then this last point, it says, this process of distributing each term that's in the first polynomial to every term in the second polynomial, that's what we were doing here, would continue even if you were multiplying two trinomials together or even two 4-term polynomials together. You're just distributing, okay? You're just taking each term in that first set of parentheses and multiplying it to all the terms in the second set of parentheses. Alright guys, well hopefully this has been helpful, and I'll talk to you soon.